Okay. Hello, everybody. Good morning. I hope everybody is fine, doing well.
Good morning, sir.
Morning,
Good morning, sir.
morning. Good. I saw one new name again. I think it is Venkata Krishnamurthy, but that name I'm not seeing it now. Does he belong to this class? Venkata Krishnamurthy, or I don't know.
Sir, it was my father's name, sir. I changed it.
Oh, okay. That's what I was thinking. What is this? Another. That's yesterday also. I mean, the Friday's class also. I had the same confusion. I had a new name. So only Strain. Other than Strain, everybody is okay, right? Everybody is old, right? Okay, Strain. How was the class yesterday? I mean, that class, the first class you attended, was it fine? Was it useful for you? Strain, are you there?
Yes, sir.
Right. Okay. I hope if you have any doubts, Kanna, like I'll give you. You can get the numbers from your classmates. Like if you know anybody from your own school who's studying here, my number will be there along with them. Right. You get the number and you can always WhatsApp me if you have any doubts.
All right, sure. Yeah. Thank you.
And like all the other chapters, videos will be uploaded in your folder, like in your drive. Right. You can also access that, and if you have any doubts, you can please contact me. Right. Okay. So we have enough people. I think we can start right away the class. Right, let me share my screen. So as discussed in Friday's class, I will just take this one class for us to complete your redox reactions chapter. Right. Okay. So what happened? Why is it coming like this? It's very sensitive. It has become very sensitive. I don't know what happened. Okay. Right. Okay. So in redox reactions, just give me a moment. I have to shoo away a crow, okay, which is creating a lot of sound. Just give me a moment. Yeah, the crow is gone. Right. Okay. So what you have to understand is from the name redox, right? You have to understand that we are going to study about reduction and oxidation. Okay, reduction and oxidation. Now, before we move on to see, we already know we have some. I mean, assuming the fact that this chapter has not been taught to you, right? We already know some of the important aspects regarding your reduction and oxidation from your lower classes, right? So we already know that in your lower class definition, reduction can be addition of hydrogen or removal. One second, guys. Okay, better. Right. So we know it can be addition of hydrogen or removal of oxygen, right? Removal of oxygen, or in terms of electrons, if I speak, gain of electron, right? Gain of electron is what is, there's something wrong with the OneNote. I think I'll just close this and again start. Just give me a moment, people. Okay, I hope this is gonna be fine. Right, okay. So we know reduction can be either addition of hydrogen or removal of oxygen or gain of electron, right? So now oxidation is going to be exactly opposite. It can be addition of oxygen or removal of hydrogen, or it can be loss of electron, right? Say now we already know what is addition of hydrogen, removal of oxygen and stuff. If I talk in terms of electrons, say for example, Na becoming Na plus by losing an electron, I would say that Na is oxidized, right? But say Cl accepts an electron to form Cl minus, I would say chlorine is getting reduced, because I told you gain of electron is reduction. This is gaining electron, so it is reduction, and sodium is losing electrons, so I would say it is oxidation. Okay, right? So these things we already know, right? Now what you have to understand is, people, right? What you have to understand is there is no reaction, right? There is no reaction where only oxidation will happen, or say there will not be one reaction where only reduction will happen, right? So what I'm trying to tell you is, if oxidation happens in a reaction, it is for sure that there is also reduction happening. Might be, you might not even see it, but if you just investigate it properly, right, oxidation and reduction will always happen together. Okay, it will always happen together. Now for me to explain you this, let me take a specific example. Okay, say I had H2S reacting with chlorine to form HCl plus S, or H2, or you want to can keep it. Okay, let me take this particular reaction, H2S plus Cl2 giving HCl plus sulfur. Right, now we'll try to investigate what exactly is happening here. Okay, now see guys, whenever we speak about oxidation and reduction, we will only speak in terms of elements, not compounds, right? I will tell, say for example, in this reaction that sulfur is getting oxidized. I should not tell H2S is getting oxidized. No, right? We should speak only in terms of elements. Say in this case, hydrogen is an element, sulfur is an element, chlorine is an element. You can speak only with respect to them. Okay, chlorine is getting reduced, sulfur is getting oxidized, sodium is getting oxidized, chlorine is getting reduced. Like that only we can speak. We should not tell that, okay, H2S is undergoing oxidation. No, you should not tell it like that. Okay, right. So we'll try to understand what exactly is happening here. Now see, in the reactant side, I'm talking, and there are, forget about hydrogen. Generally, we do not speak about hydrogen and oxygen. Generally, in any redox reaction, we generally don't speak about hydrogen and oxygen, but yeah, sometimes we do speak, right? But not in this particular reaction. Most of the reactions, you don't have to worry about hydrogen and oxygen, right? Other elements present, other than hydrogen and oxygen, those elements are the one which you're worried about. Okay, now in this case, the elements I'm worried about are sulfur and chlorine. And I just have to see what is happening to sulfur, what is happening to chlorine. Okay, now you see, in the reactant side, sulfur is here, and in the product side, sulfur is here. Right? In the reactant side, sulfur is here. In the product side, sulfur is here. Right? Now, what you are seeing here between the difference between these two, what is happening? Sulfur in the reactant side was with hydrogen, H2S. Right? Sulfur in the reactant side was with hydrogen. Right? But what happened to product side? In the product side, there is only sulfur. That means from sulfur, I have removed hydrogen. Is it not? Sulfur, I have removed hydrogen, right? So what is happening to hydrogen? Then I know removal of hydrogen is basically oxidation, right? So in this particular reaction, sulfur is getting oxidized. Why? Because in the reactant side, I had hydrogen with sulfur, but in the product side, only sulfur is present. That means I have removed hydrogen from sulfur. So I will tell that sulfur is getting oxidized. Right? Now, same kind of analogy can be given to Cl2. Right? Now, say Cl2 in this case was here, and in this case, Cl is here. So what you have to understand, this is going to get converted to this. How? By adding hydrogen to chlorine. Chlorine was alone in the reactant side, but in the product side, I see chlorine with hydrogen. That means to chlorine, you have added hydrogen. So chlorine gains hydrogen. So I would say chlorine is the one which is undergoing reduction, or say it is getting reduced. Right? So why did I tell this point is that if at all oxidation happens, reduction will happen and vice versa. One cannot happen separately. Any reaction you take, any reaction for that matter you take, you'll always have oxidation and reduction happening simultaneously. Okay, right? So this is the point I want to tell. Next point, what I wanted to talk about is oxidizing or reducing agents. Okay, oxidizing or reducing agents. Okay, now what are these oxidizing and reducing agents? Now, generally, if I have any agent, say pollinating agent, LIC agent, that agent, this agent, sales agent, whatever, what does an agent do in general? An agent is someone or something which will help me get something, right? So an LIC agent helps me in getting an LIC policy. A pollinating agent helps in pollination of flowers, right? So any agent is basically going to help in that particular process, right? So from the name itself, you can understand what I'm trying to say. Oxidizing agent, for example, will help in oxidation. Next one, reducing agent is going to help in reduction, right? Now the next question is how? How is an oxidizing agent able to oxidize something else, and how a reducing agent to reduce something else, right? Now that answer is very simple, right? The answer is sacrifice. Okay, why is it going like there is some kind of issue with this? I don't know what exactly is the problem. Okay, so the answer is sacrifice. Sacrifice what? Right. So the thing is, if there is an oxidizing agent, okay, an oxidizing agent is going to oxidize something else by undergoing reduction. Right? By undergoing reduction. So it will undergo reduction, thereby it will oxidize something else. Same way, a reducing agent, right? A reducing agent will reduce some other thing by oxidizing itself, right? By oxidizing itself. Now, finding out which is the oxidizing agent and reducing agent in a particular reaction is very easy if you understand these 2 points I mentioned here, right? Now, what is the point? Now, whichever is undergoing oxidation is my reducing agent, and vice versa. Whichever is undergoing reduction is my oxidizing agent, right? So now in this particular reaction, if you see H2S plus Cl2 giving HCl plus S, sulfur is undergoing oxidation. So that would be my reducing agent, right? Same way, chlorine is undergoing reduction. So chlorine will be my oxidizing agent. Okay, now it's very, very simple, people. Whichever is undergoing oxidation is the reducing agent, whichever is undergoing reduction is the oxidizing agent. Very, very simple. Okay, now this is these 2 points. That is, no reaction can happen only with oxidation or reduction. Reduction and oxidation will happen simultaneously. Second point to understand is whichever is undergoing reduction is my oxidizing agent and vice versa. Okay. Right. Now, this I wanted to I will take one more example for me to prove that point. C plus O2 is giving CO2. Okay. C plus O2 is giving CO2. Now, if at all you ask a 8th standard kid or a 9th standard kid, he will tell that, sir, this is an oxidation reaction. Why? Because I'm adding oxygen to carbon. Right. So carbon was alone in the reactant side, but carbon is with oxygen in the product side. So I will tell carbon is undergoing oxidation. Right. But what about O2? You have to understand that point, right? Now that you know the oxidation numbers, the oxidation number here is 0, and here you'll find that the oxidation number is -2. We'll come back to this point, but you already know it. That's why I'm telling. So oxygen is the one which is undergoing reduction. Right now, again, you see we are having both oxidation as well as reduction. So it looks like an oxidation reaction, right? But any reaction for that matter, one element will undergo oxidation, another element will undergo reduction. That will definitely happen. Okay, any questions till now anybody has? And I hope everything is clear. Am I on mute? No, right?
Clear, sir.
Okay, cool. Right, great. So that is about this. Now, next concept, what I have to see is this concept of oxidation number. Okay, the next thing which I have to see is oxidation number. Now, how do I define oxidation number? Is very simple. It is the charge possessed by an element in its compound. Okay, it is the charge possessed by an element in its compound. Any compound for that matter, you take one element, what is the charge possessed by it is what is my oxidation number. It's very simple. Okay, right. Now, there are certain rules which you have to follow for finding the oxidation numbers. Okay, right. The first rule is regarding hydrogen. Right now, hydrogen, 99% of cases, right, you will find that hydrogen can have a +1 oxidation state. Right now, it's very simple. Why we are going to have +1? It's because I'm going to have 0 electron, this stable, or I can even have -1, which happens in very rare cases. Okay. Now, obviously, -1, if I have, I'm adding electron to hydrogen, it becomes duplet configuration. That we know already. Right now, +1 will happen in most of the compounds. -1 will happen only with hydrides. Okay, hydride is an ion which is H-. Right. Say if you find that the hydrogen is kind of a highly electropositive element, EP represents electropositive atom. Right. Say for example, if you have NaH, LiH, KH, CaH2, right? All these things you see, all the elements present along with hydrogen here are what? Are more electropositive than hydrogen, right? So in all these cases, hydrogen will have a oxidation number of -1. Okay, this is the first point to note. 99% of cases, you will find that the hydrogen will have +1. Now, this will happen if I have hydrogen attached with the electronegative element, more electronegative than hydrogen. That's what you have to understand. So 99, most of the cases you will find that hydrogen is going to have +1 state, right? And only in hydrides, you will find that the hydrogen is going to be in -1 oxidation state. Now see, this oxidation number can also be called as oxidation state. Okay, please note, they both are same. Right? When I say oxidation number or oxidation state, it refers to the same thing, charge possessed by an element in its compound. Right. Next one is regarding oxygen, right? Oxygen, 99% of cases, you will find that oxygen is going to have -2. This is in normal oxides, not oxide ion, basically O2-. Okay, now oxygen can also have -1, and this will happen only in the case of peroxides, right? Say if I have H2O2, right? In this case, oxygen will have a charge of, or say will have a oxidation state of -1, not -2. You have to be very careful with this, right? And what you have to understand is the moment you see a OO single bond linkage, right? The moment you see OO single bond linkage, this is what is called as your peroxide linkage or peroxide bond, we call it, right? So in a peroxide bond, both the oxygen atoms are having -1 and -1. Obviously, I'll have other atoms present. In this case, if it is H2O2, say I'll have one hydrogen here, another hydrogen here. This is the structure of H2O2, right? So whenever you see an OO single bond, that is always going to be a peroxide bond. And in a peroxide bond, the oxygen is going to have a oxidation state of -1. Okay, right. Now, very rarely, oxygen can even have -0.5. Okay, and that will happen in the case of superoxides. Okay, it can also happen in the case of superoxides. Okay, now like don't have to worry about it. Superoxides is studied in your S&P block. Say for example, there is a molecule like KO2, NaO2, like this compound exists. Okay, now if you check for oxygen here, you will find that it is actually going to be minus half. Here also it is going to be minus half. Okay, right? Again, that is very rare. Very small amount of compounds are there which can form superoxides. Okay, but peroxides and normal oxides, yes. Now, most of the cases it will be normal oxide to -2, and if at all you see a OO single bond linkage, it is going to become -1. Right? And lastly, oxygen can also have +2 oxidation state, and this will happen only in one molecule, that is OF2. This is the only molecule, right? This is the only molecule where oxygen can have a positive oxidation state. Right? Now, why? Because fluorine is the most electronegative element. Obviously, it is going to be more electronegative, so that only will have the negative charge. So in this particular case, oxygen will have a positive oxidation state, and that is of +2. And this +2 will happen only and only in this compound. Okay, one and only in this compound. Okay, or OF2 molecule. Right? So these are the possible oxidation states for oxygen: -2 oxide, normal oxide, -1 peroxide, -0.5 in superoxides, and +2 in OF2. That is it. Right? Okay. Third point. First, we spoke about hydrogen, +1 or -1. Next, I can have oxygen. And third one is about fluorine. Fluorine can have only one oxidation state, that is -1. No other oxidation state is possible for fluorine, because that is the most electronegative element. Okay, so for fluorine, there is only one oxidation state. Okay, right? So that I want to tell. Fourth point is that when I have group 1 elements, right? Group 1 is basically lithium, sodium, potassium, and all these things. All of them can have only one oxidation state, that is +1. All of them. Okay, all of them can have only one oxidation, that is +1. No other thing is possible. Same way for group 2 elements, right? Say it is magnesium, calcium, barium, strontium, and all of that. They will always have only +2 oxidation state, no matter what. Okay, they will always have only +2 oxidation state. Right? Okay, the last and final and most important point: if you find the element in its native state, native or say free state, right? Now, for that particular element, the oxidation state is 0. Please remember this. For example, if you take hydrogen molecule, that is how hydrogen exists in nature, right? So if you ask me, what is the oxidation state of hydrogen here? It is 0. Same way for O2, it is 0. For Cl2, it is 0. Right? Now, say if I take only sodium, now sodium is, this is how it exists in atmosphere, in nature. Again, it is 0. For zinc, again, I have 0. Right? For helium doesn't matter. Say calcium, again 0. Okay? Now, if at all only sodium, only zinc, and only calcium, no other element is along with it, then definitely all of them will have 0. Right? So elements in their native state, right? If at all I have ozone, that is not 0. No, because that is not the native state of oxygen. O2, if you have, then definitely it is going to be 0. Okay, right? So these 6 points you have to remember, people, for me to calculate the oxidation numbers. Right? Okay. Now, I think I don't have to have more examples, but let me give you some peculiar. Okay, one normal example we'll do, right? And then we'll move on. Say I have H2SO4. I want to find what is the oxidation state of sulfur. Okay, I have H2SO4. I need to know what is the oxidation state of sulfur. Right. Now, obviously, you know that hydrogen here is attached to electronegative elements, so it will have +1. And in H2SO4, all the oxygen atoms are normal oxide, so all of them will have -2. Right? So now you can do this now. Now see, the overall charge of this molecule is 0. Right? In this particular case, the overall charge is 0. Okay? So you have to calculate the individual charges and equate it to 0. Because the compound is neutral. It doesn't have any charge associated with it. Right. So now how will I write this? For hydrogen, I know it is +1 because it has highly electronegative elements. So I have 2 hydrogens, each having +1, plus sulfur. I don't know. I'll keep it as X. For oxygen, I know 4 oxygen atoms are there and each of them is having a -2. So overall charge should be equal to 0. Right. If at all there is any charge, say -2 or -1 or whatever it is, that should be equated to this. But in this case, it is not neutral. Right. So now what will happen? You will find that X, that is the oxidation state of sulfur, will be +6. Okay. Oxidation state of sulfur is +6. Okay. Right. Say now another example. Maybe I'll take NH3. I want to know what is the oxidation state of nitrogen here. Right. Say now again we can do the same thing. For nitrogen, I can keep it as X. Again, hydrogen will attach to a more electronegative element than hydrogen. So in this case, you will see that +3 hydrogen atoms are there and each having +1, totally 0. So you'll find X as -3. Okay. Now say if I have to take any ion, for example, say if I have MnO4 minus and I want to find what is the oxidation state of manganese, what will you do? You'll keep manganese as X, right? And you have 4 oxygen atoms, each having -2, 0, oh, not 0. It should be equal to what? It should be equal to, in this case, -1. Whatever is the overall charge here, that has to be equated. Okay, last 2 cases, these are compounds, they are neutral, so I equated it to 0. Right? But in this case, you will see that I'm going to have overall charge to be -1. So that is what you have to equate it to. Okay, so you will find the oxidation state of manganese to be +7. Another example, K2Cr2O7 2-, right? So now see, how many ever atoms you have, that many X's you have to put. Now I have 2, so I have to put 2X. You should not put just X. Okay, so you have to put 2X plus 7 oxygen atoms, each of them having -2, and the overall charge is -2. So you will find that the X is +6. The oxidation state of chromium in this particular compound is +6. Okay, now these are all very straightforward questions. Okay, easy to find the oxidation states, right? Okay, but there can be some cases like this, right? Now, say I have NH4NO3. I'm asking you, what is the oxidation state of nitrogen? Can you tell me what is the answer? Calculate and tell me what is the answer in ammonium nitrate. NH4NO3 and NH4NO3 is ammonium nitrate, right? I want to know what is the oxidation state of nitrogen here. Go for it and tell me the answer.
Sir, -1.
-1?
Oh, sorry, +1, sir.
+1? How many nitrogen atoms I have in this molecule?
Two, sir.
So calculate it properly. Is it I think it should be -1 or +1. I think it's correct. Okay, anyways, we'll check. Don't worry.
So +1.
Sir, for 1 nitrogen atom, it's +1.
Okay, now look at this, people. Right. So if I do it by my normal method, this is how you'll do. Basically, you will write the formula as N2H4O3. Correct. We can write this formula as N2H4O3, but this is absolutely wrong. But because the answer also you're gonna get is absolutely wrong. Anyways, so now how will you do it? 2X minus plus 4 hydrogen atoms, each having +1, plus 3 oxygen atom, each having -2 is equal to 0. So what will happen? 2X plus 4 minus 6 will become -2, right? Yeah, X will be +1, right? But this is absolutely wrong, right? Why is it wrong? Is because how you look into the molecule itself is very wrong. This how you should look it as. You should look it as NH4 plus and NO3 minus. These two are the ions which came together to make ammonium nitrate. Is it not? This is NH4 plus and this is NO3 minus. Okay, so you cannot take this nitrogen and this nitrogen to be same. Please understand, right? You cannot take this nitrogen and this nitrogen to be same because they are coming from two different ions. They will have two different properties, two different oxidation numbers to be exact, right? So you have to individually calculate. For NH4 plus, you have to calculate the oxidation of nitrogen. For NO3 minus also, you will find you have to calculate the oxidation of nitrogen separately. And then you will get the answer. And that answer you will get individually can be correlated to this value which I got. I would say this is the average oxidation number, right? Whatever the value you got here, right? You calculated just it as 2x and did it, right? So this value will be an average of the oxidation number, which you're going to get from these two, right? So we'll see how to do it now. It's very simple, right? Now X is the nitrogens is the oxidation state, and I have 4 hydrogens, each having +1, and the overall charge is +1, right? Here it is a plus, right? So what will you find? X is -3. For this nitrogen, it is -3, right? Okay. Same way for this nitrogen, if you check, right? Now I have X plus 3 oxygen atoms, each having -2 is equal to -1 because the overall charge here is -1. Okay, what will you find now? This
+5.
Is equal to +5. That's what you'll find, right? So these two are the individual correct answers. In NH4 plus, you will have -3 for nitrogen, and NO3 minus, you will have +5 for nitrogen. Okay, now you take the average, no, right? Now if you take the average, what will happen? Oxidation state average will be this one, that is -3, this one +5 divided by the number of nitrogen atoms. Number of nitrogen atom is what? 2, right? So you will find that the average oxidation state is +1, right? But that should not be the final answer. You have to find the individual nitrogen atoms is oxidation state. Then you can calculate the average, and that you will find to be normally how you calculate that answer will come. But that is not correct. These two are the correct answers, -3 and +5. Okay, right. So like this, I have another example for you. Say if you take Fe2, no, not Fe2O3, Fe3O4. Okay, if you take Fe3O4, try to calculate and tell me what is the value you are getting for iron. I want to calculate for iron, obviously. Tell me what is the value you are getting for iron. Yes, what is the value you are getting? What is the value you're getting? It's only mathematics, right?
Sir,
Come on,
if
guys.
you just directly calculate the
I
oxidation
want the
number,
direct calculation answer only I'm asking. I don't want you to know what exactly is happening. Directly, if you calculate, what are you getting?
sir, I'm getting X is equal to 8/3.
8/3. Okay, that's correct. Anybody else is getting 8/3? If you normally calculate? Okay, I don't know whether you guys are calculating. It's very simple to understand. I have 3 iron atoms, so 3x plus 4 oxygen atoms, each having -2 is equal to 0. So you will find that X is plus 8/3. Right. Now, please understand this. Okay. How can a charge be fractional value? Not possible, right? Or in general, oxidation numbers or in general charges cannot be fractional values. It cannot be any decimal values. Okay, so it means something is wrong in this molecule. And or I would say something is wrong in the way in which we look at the molecule. If you know how to look at the molecule, then you'll get the correct answer. Okay, now these kind of oxides, which I wrote here, I have one more thing also, Pb3O4. This also exists. Okay, so these kind of oxides are what are called as mixed oxides. Okay, these are what are called as mixed oxides. That means they are combination of two or more oxides put together, right? So please understand, Fe3O4, I will be able to write it like this: FeO plus Fe2O3. Is it not? FeO plus Fe2O3 will obviously is going to give me what? Fe3O4. Same way, PbO plus Pb2O3 will give me Pb3O4. Right? So even though the formula is Fe3O4, it's not exactly the formula. It's actually a combination of FeO and Fe2O3. Okay, same goes with here, PbO and Pb2O3 forming Pb3O4. Right? So these are what are called as mixed oxides. Okay, now definitely in FeO and Fe2O3, you will find that there will be two different oxidation states. Correct? Now, if you calculate for FeO, what will happen? X minus 2 is equal to 0, X is plus 2. Same way, for Fe2O3, if you calculate, I'll have 2X plus 3 into minus 2, because 3 oxygen atom having minus 2 is equal to 0.
Sir, it
So
is
X
plus
will find
3.
plus 3. Right? So plus 2 and plus 3, both oxygen states are possible for iron. I think this question came long time. So many times people have asked me, I think in this class only, why like iron exists in that plus 2 as well as plus 3. Now that we'll see later. But for now, you understand that it can have both plus 2 as well as plus 3. Okay, now how can I connect with this 8/3 value? Again, it's nothing but the average, right? So if you take the oxidation state average, what happens? There is one Fe with plus 2 oxidation state, and there are 2 Fe's with plus 3 oxidation state. So 2 into plus 3, I have, that is, there are 2 iron atoms with plus 3 oxidation state and 1 iron atom with plus 2 oxidation state. Totally, there are 3 iron atoms. So what will you find now? This value is going to be 8/3. Okay, so whenever you get a fractional value like this, or whenever you see like nitrogen having a -1 oxidation state here in this case, right, or +1 oxidation state, nitrogen can never form +1. Look at the octet rule. For me to satisfy octet, look at what are all the possibilities. Say one of the possibilities, obviously -3, right? That you got here. I can add 3 electrons to nitrogen, so it becomes 2,8, right? Or from 2,5, I can remove this 5 electrons, so I can have +5 oxidation state. The duplet will be satisfied. These kind of things only will happen. +1 or -1 to nitrogen really doesn't make any sense, right? Because then obviously it is not going to get stabilized by duplet or octet, right? That is one way of looking into it. Second way of looking into it is by the moment you see fractional values, 8/3, 4/2, whatever, 4/2 is 2, it's telling you, anytime you see a fractional value, definitely there is something wrong with the molecule. They have to look at it into a different way. Okay, please keep these 2 things in mind. Other things are very, very simple. Normally, how you can calculate the oxidation states. But these things are little classy, right? Now, there's one more. Now, there's another way of looking. There are another type of problem you will face. Okay, say if I take CrO5. Okay, if I take CrO5, now tell me what is the oxidation state of chromium here. Can you normally the normal method you calculate and tell me what is the oxidation state of chromium.
+10, sir.
+10, right? It's very easy to calculate. So X for chromium plus 5 into -2 for oxygen is equal to 0. So you will find X as +10, right? Now guys, oxidation state, like remember osmium tungsten is W, capital W, right? These are the only two elements which can have a maximum oxidation state in the entire periodic table, and the maximum oxidation state possible is +8. Okay, maximum oxidation state possible for any element in the periodic table, that is osmium and tungsten, these two are the only things that are capable of doing this, can have +8 oxidation state. If I have to give you the compound OSO4, it's called osmium tetroxide. Okay, in osmium tetroxide, you will find that osmium is in +8 oxidation state. It is possible, right? But more than 8, never it is possible in periodic table. At least not on the Earth's, not on the elements present on this Earth. Maybe in some, if you go to Mars and you find a new element, maybe that is capable of doing it. But right now, the elements present on Earth in this planet, maximum is osmium and tungsten, which can have a +8 oxidation state, right? So why did I tell you this? Is because obviously this is wrong. I cannot have +10, right? Now, the first way of looking into is in terms of octet or duplet. Obviously, that is one way of looking into it. Second way of looking into it is when you get a fractional value, then obviously you understand that something is wrong. And third thing is when you get an oxidation state greater than 10 or greater than 8, sorry, that is again a problem, right? And actually, for these kind of questions, and let's say 2 more problems we'll solve. For those kind of questions, you have to know the structure of the molecule. If you do not know the structure, you will not be able to answer the question. Right? Now, if you look at CrO5's structure, this is a famous structure called a butterfly structure. Right? It's called a butterfly structure. Right? And what is the butterfly structure? I'll tell you in a minute. People, I'll be back in a minute. Please give me 30 seconds. I'll be back. Okay. Sorry guys, there was a small problem. Okay, so I was talking about CrO5, it cannot have +10. And I told you this structure is a very famous structure called the butterfly structure. Okay, so why is it called as a butterfly structure? Because the structure is going to be like this. Cr double bond O, 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 O. Okay, this is what I have, right? Now, what will you find is that this is the exact structure which I'll have for CrO5. Okay, this is the exact structure I'll have for CrO5. Okay, now does it not look like a butterfly? I hope it looks like a butterfly, even though my drawing is bad, almost looks like a butterfly. Right. Okay. So now, if you check what is the oxidation state of this particular oxygen, this is a normal oxygen, double bond O is there, right? So this will definitely be -2, right? But look at these 2 oxygens and these 2 oxygen. What should be the oxidation state of these 4 oxygens, people? Sorry?
-1.
-1. Why?
O linkage.
Why? What?
O linkage, sir.
OO single bond linkage is there. You can see there is a OO single bond linkage is there. That is a peroxide linkage, basically. Right? I will tell. I have a peroxide linkage here. So these 4 oxygens are going to have -1, -1, -1, and -1. Right? Now you calculate the oxygen state of chromium here, X, right, plus 1 minus 2 oxygen. This is the -2 oxygens I have. And there are 4 -1 oxygens. So you will find that the X is equal to 0, obviously. You will find that the oxygen state of chromium is +6, not +10. Okay, people, any questions anybody has? How will I know the structure, sir? You have to know the structure, Kanna. There's no other go. Okay? Or it's very easy to understand that it cannot be +10. It is impossible for chromium to have +10. I told you maximum is only +8. Right? So like that, I can have one more example I can give you, and we can stop with this. Oxidation states. Okay, 2 examples I will do. One is S2O8 2 minus, and another example I want to do is S4O6 2 minus. Am I right? Yeah, right. S8 S2O8 S2 only, right? Yeah, S2O8 2 minus, and this is also S4O6. I'm sorry, this is S4O6 2 minus. Okay, S2O8 2 minus and S4O6 2 minus. Okay. Now I want to do, if you calculate again, right, you will find that I'm going to have some crazy things coming out, but that is not the way of looking into it. See, for these kind of compounds, you have, as I told you, have to know the structure. Okay, you have to know the structure. Okay, now the structure of S2O8 2 minus is like this. Okay, S double bond O. There's another S having a double bond O, and there are 2 oxygen atoms having minus and minus. Done. Okay, I'm sorry, I will say there are 2 S double bond O's on each of the sulfur atoms and 1 O minus on each of the sulfur atom. Okay, now how many oxygens are missing? 1, 2, 3, 1, 2, 3, 6 oxygens done, 2 more oxygens required. Right, now that will be a OO single bond. Okay, that will be a OO single bond. Now it's very easy to understand, people. Here it is -2, here it is -2, here also it is -2. Like, even though you see that there's a negative charge and a bond, there's a -2. Same way, -2, -2, -2. But these 2 oxygen atoms are going to have -1 and -1. Okay, these 2 oxygen atoms are going to have -1 and -1 because the peroxide linkage. Very simple. Okay, now if you calculate the oxidation states, right, it's very simple, no? So you have -2, -2, -2. No, this should be -1, right? I'm sorry, like, but I'm getting +7. I should get +6. Okay. Guys, I'm so sorry. I messed up one thing. When you have O minus, okay, when you have O minus, for that also you give only -1. Okay, so for that also you give -1. Now let me explain you very clearly. Let me finish this and explain you why is it like this. Okay, so this and this are -1 and -1. Okay, I'll explain you how this comes. Don't worry about this. Okay, right. Now you see this sulfur will have -2, -1, -2, -1. Totally, you will find that this sulfur will have a +6 oxidation state, and this sulfur will also have a +6 oxidation state. Okay, now going back to this point, why when I have O minus, I have to keep -1 is because it's very straightforward. I have a negative charge directly associated. So definitely that is going to be -1. Right. Now, if you get confused, the actual compound for this is H2S2O8. Okay, H2S2O8 is the actual compound for this. Okay. Now what you understand is there are how many oxygens? Basically, only 2 of the oxygen atoms are having -1, -1. Rest of all the oxygen atoms are having -2. Now in this case, why am I not taking this oxygen as -1? Because this is not a O minus anymore. This will become a H. Okay, this will become a H, and this is also going to be -2 and -2. I hope you are able to get. I hope you are able to understand what I'm trying to say. If last case I had only O minus here, let me draw the structure again. I'll at least draw only one side of the structure. S double bond O, and I had a O minus here, so you gave -1 here. But in this case, what I'm doing is I have a OH. Okay, I'll write like this: OH. Again, double bond O. And these two are -1s, no problem. These two are -2s, very straightforward. Now this is also having 2 bonds, so straightforward I can say it's -2. But if I had a negative charge here, then at that case I will give -1. Okay, now you calculate for the oxygen state of sulfur here. I have 2x for 2 sulfurs plus 2 into +1 for 2 hydrogens, and I have 6 oxygen atoms having -2. Only the middle 2 are having -1 plus 2 of the oxygen atom are having -1, it is equal to 0. Now if you calculate 2x plus 2 -12, you will find that this is +2 -2 gets cancelled. Yeah, you will easily get x. This is 12, so you'll find that the x value is +6. Okay, so when you have a O minus, you give -1 directly the charge associated. But if at all you have nothing, then you have 2 possibilities: -2 or -1. Normally we'll give -2, but if you have O single bond linkage, that becomes -1. Okay, right. Now what you do, like this is for S2O8 2 minus, right? Now let us do it for S4O6 2 minus. Okay, S4O6 2 minus. Now I'll give you maybe 2-3 minutes. Try to get the correct structure. Try to get the correct structure of S4O6 2 minus. I'll give you 2-3 minutes time. Okay, check it out. If anybody got the structure, you can send me in WhatsApp. I'll look into it. Yes, anybody have it with you? The structure? Okay, so then I'll do it. right? So this is how the structure looks. Now in this particular case, 4 sulfurs directly attach 4 sulfurs like this. Okay, directly attach 4 sulfurs like this. Okay, and in right, so 2 double bond O's on each sulfurs, 2 double bond O's on this sulfur, 1 O minus, another O minus for another sulfur, 2 sulfurs. Okay, right. Now calculating for this sulfur and this sulfur is very easy. Now I can tell this will be -2, this will be -2, this will be -1, right? So you will find that this sulfur is having +5, this sulfur will also have +5. But what about these 2 sulfurs? Right. Now please understand, people, just because you gave OO single bond linkage -1 and -1, but you see there are other atoms present here. If there is something called as a per-sulfide linkage also, per-sulfide linkage, peroxide linkage, all of them are going to have SS. But you need to have some other element present on these 2 sides. Say this can be hydrogen, right? Or this can be oxygen. It can be any other thing, but it cannot be sulfur and sulfur. If you have something like this, right? Now I will not call any of these bonds as per-sulfide bonds, right? This is equivalent, right? This is equivalent to have S double bond S. Is equivalent to have S double bond S. So what I'm trying to say is that these 2 sulfurs are there in their native state, right? These 2 sulfurs are there in their native state. So for them, what should be the oxidation state value if they're in native state? If they're in native state, what is the value?
0.
0, right? So for these 2 sulfur, it is 0. Please understand this. Okay, if you have only SS and this side some other element and this side some other element, you can blindly give -1 because it's a per-sulfide linkage, right? But if you have all the 4 sides hydrogens, sorry, all the 4 are sulfurs, then you cannot consider as a peroxide bond. These are considered to be the sulfur is in its native state. So I will give 0 and 0. Okay, right? Now it's very simple. 2 of the sulfur atoms will have +5 and +5. The other 2 sulfur atoms are going to have 0 and 0. Okay, so 4 sulfurs, right? These 2 are having +5, +5. These 2 are having 0 and 0. Okay, now more than this, they can never ask you in any exams, like at least in your board exams or in your school exams. They cannot ask you anything more than this. Okay, just remember the structures and assigning what kind of numbers to what oxygens, what sulfurs. That if you know, you are set for the exam. Okay, I hope I made some sense. I hope everybody understood. If there is anybody who want me to repeat again what I said now, everybody's okay, right? Okay, I hope everything is fine, right? If not, you will ask me. Please do not hesitate to ask me. You can always ask me anything, everything, obviously with respect to subject. If you want to personally speak, yes, we can speak, but not here in WhatsApp, right? Okay, so that is about oxidation numbers. Okay, right. Now, why did we study this? Is to study again oxidation and reduction. Okay, now oxidation and reduction, we are not anymore going to speak in terms of removal of hydrogen, addition of oxygen, electrons and stuff. We are going to speak only in terms of your, oxidation numbers. Okay, so again, I'm repeating, we will speak that a certain thing is getting oxidized or a certain thing is getting reduced. That certain thing which I'm telling can be only elements. You cannot tell that MnO4 minus is undergoing reduction. You should tell manganese in MnO4 minus is undergoing reduction. Like that only you should speak. Okay, fine. So keeping that in mind, we can easily say that oxidation is gain or say, gain or increase in oxidation number, right? Say for example, Na becoming Na plus Here the oxidation state is 0. Here it is +1, right? So obviously you see there is an increase in oxidation number. So this will become oxidation. Okay, fine. Now reduction is obviously opposite. When you have a decrease in oxidation number, that is going to be called as a reduction. Okay, so this is definition of oxidation with respect to the oxidation numbers. Okay, right. Now the last part of the chapter talks about balancing or redox reactions. Balancing redox reactions. Balancing reactions we can have, not a big deal. Okay, balancing a redox reaction. How will we do it? Using this oxidation numbers only. Okay, now there are two methods of doing it, right? But I'm going to teach you only one method. Okay, the other method is a little complicated. If at all you are familiar or say comfortable with that method, you can follow that. If not, I will suggest the method which I'm going to follow now, right? And that is called half reaction method. Okay, it's called half reaction method. The other one is oxidation number method. Oxidation number method that we are not going to use. If you're familiar and comfortable, then go for it. There is no restriction that you have to use this method only, but I will suggest you to use this method only, half reaction method. Okay, right. Now, what and all of the steps you have to follow for a half reaction method? First, draw the skeletal, write the skeletal equation. Right? Write the skeletal equation means the unbalanced equation. Okay, write the unbalanced equation first. Right. Second point is that for all elements except oxygen and hydrogen, right, find out the oxidation states. Right, find out the oxidation numbers of all the elements except for hydrogen and oxygen. But again, this can happen I would say forget about this point. Right, all the elements is oxidation state you find. That's the second point. Right? Oh, why am my handwriting is so bad today? Already it is bad, and because of this, some glitch in the slate which I have, it is becoming horrible. Okay, fine. So for all the elements, find out the oxidation state, including hydrogen and oxygen. Right? Fine. Third point. Right, now once you find the oxidation numbers, obviously you will find it in the reactant side, sulfur in the reactant side oxidation number, sulfur in the product side oxidation number. You will be able to compare now. Right, so now you will find out which element is oxidized and reduced. Obviously there will not be same element. It can be same element, right? But most of the time you will find that one element will get oxidized, the other element will get reduced. You have to understand which element is getting oxidized, which element is getting reduced. Now it is based on this particular thing which I wrote. Oxidation means increase in oxidation number, reduction means decrease in oxidation number. Okay, fine. Now after finding out which is oxidation and which element is undergoing oxidation, which element is undergoing reduction, now find out, after that, write the half reactions. Write oxidation and reduction half reactions. This is like, obviously, I'm going to take only oxidation and write. I'm going to take only reduction and write. Oxidation and reduction half reactions. Now, along with the number of electrons lost or gained. Okay, it's not only about oxidation and reduction. You must, I know for oxidation, I would have lost some electrons, right? How many electrons are lost? That also you have to mention in the reaction. Same way, for reduction, I know it is gain of electron. How many electrons are gained? Again, that you have to specify in the reaction, half reaction, which you write. Okay, now, after doing this, right, make, right, number of electron lost equal to number of electrons gained by suitably multiplying with the factor. By suitably multiplying with the factor. Okay, we'll see what I think you already know what I'm speaking. I'm just letting you know, right? And after doing that, right, now you obviously after multiplying with the factor, what you will be getting is the modified half reactions, right? Because you have multiplied with the factor now, right? So modified half reactions add them. Okay, once you make the number of electrons gained and number of electrons lost to be equal, right? Obviously, you will have multiplied the entire half reaction with some number. So obviously, what you will be getting is a modified half reaction, and you add the modified half reactions. That's it. Okay, and the last and final step after adding this is my charge balance. Okay, the last step is is for charge balance. Okay, so what do? You calculate the total charge on the reactant side, right? I will tell charge on the reactant side should be equal to the charge on the product side. Okay, so you have to calculate what is total charge on the reactant side, total charge on the product side, and you have to do something to make these charges equal, right? So that is going to depend upon what is the medium they are giving. This depends on what is the medium, whether it is acidic medium or whether it is basic medium. Okay, whether it is acidic medium or basic medium. Okay, right. Now what you have to do, if it is acidic medium, add H plus on the appropriate side, on the required side, right? And for satisfying or say for balancing hydrogen, add H2Os in the opposite side. Obviously, say if you added 2 H plus in the reactant side, right? Obviously, in the product side, 2 hydrogens will not be balanced, right? So you add 1 H2O on the product side. Hope you understand. Say this is the reactant, for example, reactant product, right? Say for example, the charge was not balanced, right? And I add 2 H plus to this, to the reactant side. So to satisfy this hydrogen, you add 1 water molecule on the product side. That's what I'm trying to say. Okay, now you have to look at into only hydrogens and not the oxygen. Don't worry about oxygen. Okay, do not worry about oxygen, right? And if it is going to be basic medium, then what will you do? I'll write here because I don't have space. If it is basic medium, add required number of OH minus in the required side. Again, it can be the product or the reactant side. And to balance oxygen, add water on the opposite side. Okay, last time you were adding H plus and balancing for hydrogen. Now in this case, what will you do? Add OH minus in the appropriate side, and for balancing oxygen, add water molecule. In this case also water, that can also water, but this time it is for oxygen balancing. In acidic medium, it is for hydrogen balancing. Okay, now these all points step by step, if you follow, you are going to get perfectly balanced redox reactions. Okay, what is the first step? Write the skeletal equation. Second step would be to write the oxidation numbers of all the elements present, right? And third thing is that after writing the oxidation states, check whether it is oxidation which is reduced, and you know how to do it. Increase in oxidation number, oxidation, reduction, decrease in oxidation number, reduction. Right. Now, once you find out, now the next step would be to write the half reactions. Right. Now, half reactions means whichever is getting oxidized, take the neuron separately. Whichever is getting reduced, take the neuron separately, but you have to include the number of electrons lost and gained also. Right. And in the next step, what you do is you have to make the number of electrons lost and gained to be equal by suitably multiplying with the factor, the half reactions. You have to multiply the half reactions itself with some suitable factor so that the number of electrons lost and gained are equal, so that get cancelled when you do the next step. When you add the half reactions, when you add the modified half reactions, there will be no electrons because you have made them equal. They will cancel, right? So now you will get the modified half reactions by adding the basically you have to add the modified half reactions, so you will get the full reaction. And once you get the full reaction, there will be still things left, and the last step would be to do charge balance. And that depends on whether I have acidic medium or basic medium. Acidic medium need had H plus on one side and H2O on the opposite side. The number depends, right? Same way, if it is basic medium, add OH minus on one side and add H2O on the opposite side. Okay, right? So now we will do some couple of examples, okay, and then we will try to wind the chapter today itself. Okay, right. Now let me take an example for, I think like the example, I think that day, I don't know how many of you were there, only 2-3 people were there. So I'll take the same example today. We'll try to explain this. Okay, fine. Say first reaction is M1O4 minus reacting with Fe2 plus forming Fe3 plus plus Mn2 plus, and the reaction is happening in acidic medium. Okay, the reaction is happening in acidic medium. Okay, right. So obviously I have to add H plus, and that anyways is going to be used only in the last step of the reaction. Right. Fine. Now, this is, I already wrote the first one. First step is over. Writing the skeletal equation. Yes, I wrote the unbalanced equation. That is my skeletal equation. Right. Now, what I have to find is my this what is second this thing. Find the oxidation states of all the elements. Right. Now, you will find that the oxidation state of manganese is +7. For oxygen, it is -2. But you don't write generally write for oxygen and hydrogen. But still, we'll write for iron. There is no this thing here. Directly, it is +2. And directly, I can write here +3. And directly here I can write +2. Okay, right. So now you see that manganese in MnO4 is having +7, but in the product side you see that it has become +2. So there is decrease in oxidation number. So manganese, I would say, is getting reduced. Manganese is reduced. Okay, now what is the next thing? Iron is the next thing. +2 in the reactant side, +3 in the reactant side. Increase in oxidation number. So iron is getting oxidized. Done, right? So we wrote the skeletal reaction. We found out the individual oxidation states. Now we decided which is undergoing oxidation and which is undergoing reduction. Right? What will be the next step? Next step will be to write the half reactions. Right? So write the half reaction. MnO4 minus becomes Mn2 plus. Obviously, I know here it is +7, here it is +2. I know I need to add how many electrons? Obviously, it is reduction. So I have to add electron, right? So adding 5 electrons to MnO4 minus will make it to Mn2 plus. Is it not? Here I have 5 electrons gained. This is how you write the half reaction. This is my reduction half reaction. Okay, reduction half reaction, right? Okay, next what is happening? I have to write for Fe. Fe is undergoing oxidation, right? So Fe2 plus is forming Fe3 plus. Obviously now I have to I should have lost electron because it is oxidation. And how many electrons is very simple? Only 1 electron here, right? So now this is my oxidation half reaction. Okay, now what is the next step? I have to make sure that the number of electrons lost and number of electrons gained are equal. Right? Number of electrons lost and number of electrons gained are equal. So I have to suitably multiply with the factor. Right? Now in this case, the best way to do this is by multiplying this reaction by 5. Okay, multiplying this particular reaction by 5. If I multiply this 5, now 5 electrons lost, 5 electrons gained. That's it. Right, 5 electrons lost here and 5 electrons are already, right, 5 electrons are already gained here, so they will get cancelled once you add the modified reactions, right? So when you multiply this reaction by 5, I will get 5 Fe2 plus becomes 5 Fe3 plus 5 electrons. Okay, now this is my modified oxidation half reaction. In this case, I am not modifying anything with the reduction half reaction because nothing is required. If required, I can do that, but this case is not required. Right? So now what you do? You have to add this reaction with this reaction. Now when you do it, what will happen? 5 electrons gets cancelled. So what is remaining is MnO4 minus plus 5 Fe2 plus gives 5 Fe3 plus Mn2 plus. Right? Now this we got. Right? Now going for the last step is your what? Charge balance. Right? So for that, first you need to calculate what is the charge on reactant side and what is the charge on product side. right? Okay. Now you see here, I have no number, only one here. So 1 into minus 1 is minus 1 plus 5 into 2. I have this is having a plus 2 charge, and there are 5 such things. So I have 5 into plus 2. You will find that it is minus 9, right? 10 minus 1 will become 9, not minus 9, plus 9. Okay. On the reactant side, I have plus 9 charge, total charge. Okay. Now let us do it for the product side. I have 5 ions which are having plus 3 plus only 1 Mn2 plus, so 1 into plus 2, right? So what do I have? 15 plus 2 will become 17. Okay, 15 plus 2 will become 17, right? Now, obviously you see that the charge is not getting balanced. Okay, the charge is not getting balanced, and they told that it is going to be acidic medium, so definitely I have to add H plus. Okay, I have to add H plus, and obviously I have to make it more positive, right? The reactant side charge is high, less. The product side is having more positive charge. Obviously, I have to add more positive charge to the reactant side, right? And it's very simple. 9 plus X, meaning I should have some amount of X, so that becomes equal to 17. And I think it's very much understood that the X should be plus 8, right? Because plus 9 plus 8 will become plus 17. Right? So what I have to do, I have to add 8H plus on the reactant side. Now, when you add 8H plus, 9 plus 8 will become 17. Already 17 is there in the product side. Okay. Now, this is not done yet. You have to satisfy hydrogen. Okay. Now, you have added 8H plus. So I need to have 8 hydrogen in the product side also. So you will add water molecule. And how many water molecule is very simple. I have to add 4 water molecules. 4H2. So that I have 8 hydrogens here, right? And 8 hydrogens here. Probably 8. Now this one, MnO4 minus plus 5Fe2 plus 8H plus gives 5Fe2 plus Mn2 plus 4H2O. This is my balanced reaction. Okay, this is my balanced reaction. Okay, anybody has any questions? Anybody wants me to repeat any of the points which I wrote here? Anything, anybody, any queries? Okay, fine. Time is 12:50. Maybe I'll solve just one more question. Right? Okay, let us take, maybe I'll see what I can do. Okay. I have K2Cr2O7, or I can even just write it as Cr2O7 2 minus plus SN2 plus, that is tin, right, is forming SN4 plus Cr3 plus. Okay, exactly same thing again, acidic medium. Okay, this happens in acidic medium. Basic medium question will be very rare. Okay, you will not, I don't think you will be getting basic medium questions. Okay, fine. Anyways, so now this is an acidic medium. It's given in the question, right? So now again, same thing you have to do for entire all the distinct people. So now I have to find the oxidation numbers. You will find that for chromium it is +6, for oxygen it is -2, and directly it is +2, directly it is +4, directly it is +3. Right? Now once you identify this, we can identify which is undergoing oxidation, which is undergoing reduction, right? So +6 to +3, there is decrease. So this is my reduction, and what happens? So +2 to +4 oxygen you leave, doesn't matter. So +2 to +4, increase in oxidation number. So oxidation. Now I have to write these two reactions separately. Okay, first we'll write the reduction reaction. Cr2O7 2 minus becomes Cr3 plus. Now, whenever you see there is a difference in number of atoms, you can see here, I have 2 chromium atoms. Here I have only 1 chromium atom. The first step would be to put 2 here. Do not forget this. Okay, do not forget this. We are writing a half reaction. At least the half reaction should be balanced by itself. Is it not? Here I have 2 chromium atoms. Here I have only 1, so I put a 2 here. Okay, now you calculate what is the number of electrons gained, obviously, because it is reduction. Right. Now what I understand is for chromium +6 to become chromium +3, 3 electrons should be added. 3 electrons should be gained by Cr6 plus. And that is for 1 Cr6 plus. How many Cr6 pluses I have? I have 2 Cr6 pluses I have here. Cr2 is there. So 2 chromium atoms are having +6 oxidation state. Okay, so 1 chromium 6 plus becoming 1 chromium 3 plus, 3 electrons. So 2 chromium 3 plus become, 2 chromium 6 plus becoming 2 chromium 3 plus. I have to add how many electrons now? Obviously 6 electrons I need to add. If you put 3 here, the entire question is wrong. Even though it is +6 to +3, 3 electrons, but that is for 1 chromium atom. Right? Here I have 2 chromium atoms, so you have to double it. So in this case, it will be +6 electrons. 6 electrons should be added on the reactant side when it accepts to form the reduction process. Right? So this is my reduction half reaction. Okay, no issues. Right? Now, I'll go for the oxidation half reaction. Now, it's very simple. SN2 plus is becoming SN4 plus. Obviously, now the difference is +2. So I should have lost 2 electrons. I should have lost 2 electrons. Okay, now that's it. This is my oxidation half reaction. Now the next step would be to what? Next would be to make the number of electrons lost and gained to be equal. And the easiest way to do it is multiply this reaction by 3. So that this will become 6 and there are already 6 electrons here, they will get cancelled. So if I write the modified oxidation half reaction, I'll have 3SN2 plus giving 3SN4 plus 6 electrons. Right? Now what do? You take this reaction and add this reaction. 6 electron gets cancelled. So you will get the equation like this. Cr2O7 2 minus plus 3SN2 plus gives Cr3 plus 3SN3 plus. 4 plus. Right? Done. Now what I have to do is charge balance. Right? And they've given it acidic medium. Now calculate the charge. Here I have 1 into -2 is -2. 3 plus 3 into +2 will become 6. Basically 6 minus 2 will become +4. This is what I have it in the reactant side. Now go to the product side. I have here 1. So 1 into 3 plus 3. 3 into +4 is 12. 12 plus 3 will become 17. Okay. So there is some problem. Anyways, we'll check it out. Is it correct? 3.
Actually, sir, I think you made a mistake.
Sorry?
Sir, I think somewhere you made a mistake, sir.
Yeah.
It's 2 Cr3 plus.
Oh, that's the problem. But again, that is not going to make any difference here. But still, it is 2 Cr3 plus. So it is going to be 2 into +3. So anyway, so it is +6 plus 10. Correct. So +6 plus 12 will
Sir?
be 22, right? Yes.
Sir, I think there should be 4 electrons in the reactant side, right?
Here I should have only, this is 3 electron into 2 will become 6. Here I have 2 electrons into 3, correct only, no? SN2 plus will become SN4 plus. I wrote SN4 plus only, right? Yeah. I should have lost 2 electrons. So into 3 it will become 6 electron, correct only, right?
No, sir, in the first one, the Cr2O7 minus.
Cr2O7 2 minus, what is the charge here? charge is +6 for 1 chromium, and here it is +3. So for 1 chromium 6 to 1 chromium 3, it is 3 electron. 2 chromium means 6 electrons.
Sir,
Go on.
yes, sir, 6 electrons, and then over here 2 electrons. So it will cancel and become +4 electrons, right?
Oh, wait, I am not adding this, right? What is the motto of us? I want to make sure that this number electron lost and this number electron gain should be equal. That is why I multiplied by 3. So that becomes 6 and 6 and they get cancelled. Do you get the point?
Oh, okay, sir.
Right. Okay, good. Right. So yeah, the small mistake is I missed a 2 here. So now it is +22 on the what side? On the product side. Right. So obviously it's acidic medium. So can I say +4 plus 18 will only give me +2, sorry, +22, right? So obviously it's understood that I have to add 18 H plus on the reactant side, and accordingly you have to add water molecule, and it's easily understood that I have to add 9 H2O. So the 9 into 2 will become 18. So that's balanced. Okay, so this is the balanced equation for this particular reaction which I asked you here. Okay,
Sir.
so everything is clear. Yeah, any questions anybody has?
Sir, so finally, in the answer, there should be no adding of electrons in either.
There should be no electron in the final reaction. No reaction, no
Okay,
electron.
sir.
Yeah, that's the whole point. Yes, correct. Okay, anybody else has any other questions? Fine. So I have to teach you disproportionation and contraproportionation reaction. So that might take only half an hour. It's all about solving it. Okay, so that we'll do next class, and next class I'll be starting with the gaseous state. Okay, so first half an hour redox reaction. The next 1 hour would be gaseous state. Right? Fine. I'll stop sharing here. Any questions or any queries you can ask now. Anything you know, anything you want to ask.
Sir, when will we start organic chemistry?
No, Kana, it will take some time. Okay, because we will have to complete 3 big chapters. I will not say gaseous state is a small chapter, but after gaseous state, we have to go for thermodynamics, big chapter. After thermodynamics, even a bigger chapter, equilibrium will come. So it will take some time. Say now it is September. Like I mean, almost September. Yeah, September almost ended. So you have October, November, December. Most probably I'll be able to start organic only by December last week or January first week, approximately. Okay, sir. Because I don't think you have organic chapters are there for your first term. Do you have organic? There's GOC, general organic chemistry, and hydrocarbons are the only 2 organic chapters I have. But I don't think you have that in first term. Is it correct?
Yes, sir.
Right. So in the first term, I think you will have the first 4 chapters, that is some basic concepts of chemistry, atomic structure, periodic table, chemical bonding, and redox reaction. And 1 more will be there. I think the 1 more would be gaseous state. Correct, guys? Yes or no? You don't know what chapters are there in term 1.
I'm not sure with it, sir.
You're not
So
sure.
term 1 has hydrogen and organic chemistry, sir.
Oh, term 1 has organic chemistry also.
Yes, sir.
Okay, can you please confirm it next class? Can you please, or anybody knows, get to know, please WhatsApp me, sir. These are the chapters which are there for, excuse me. Right. So these are the chapters which are there for term 1. I want the list of chapters. Anybody who gets to know, please WhatsApp me. Okay. So because if if gaseous state is not there in term 1, we can directly, if gaseous state, thermodynamics, and equilibrium is not there in term 1, we can directly go for organic.
Sir, actually organic is there, sir. I checked now.
Organic is there in term 1. Both the
Yes,
chapters are only general organic chemistry.
Sir, hydrogen
chapters,
and general organic.
Okay, general organic chemistry and hydrocarbons, both are there. Then cool.
Yes,
Then
sir.
so next class we'll start with general organic chemistry if that's the case. Okay, right? But after me starting, if you tell me that, sir, no, it's not there, the loss is yours because the time would be wasted. Okay, so it is confirmed, right? Both the organic chapters are there in group 1. Is it confirmed?
Yes, sir.
Okay, cool then. So I believe your word because I don't, or I'll also check in the Google or internet, right? So I'll also confirm, but I think as if you are saying this much confidently, then it should be the case. So next class, I'll be finishing your redox reactions and I'll be starting with GOC, my favorite topic. Okay, you are going to love it as much as I love organic chemistry. I'm going to make sure that you are also going to fall in love with organic. Okay, so that being said, right, I think we can wind up the class. Thank you so much, people. We'll meet again on next week.
Thank you,
Melinda.
sir.
Thank you.
Thank you, sir.
Yeah.